This is part 5 of the Earth's atmosphere topic in GCSE AQA chemistry. It's a dual award topic, so it's valid for dual and triple award students. I'm going to recommend you pause and have a go at the activity before we review it. In this particular video, the final in this series, we're going to take a look at the different forms of atmospheric pollutants, how they're caused, what problems they cause, and any relevant equations that go with them. It is really important in GCSE chemistry that you don't just talk about pollution. We need to know what specific pollution is happening in specific situations. So I'm going to recommend you try and draw out a mind map. And when you've done it, come back to this video. And in the mind map, have a think about what causes the different pollutants. And I'm going to tell you what the pollutants are in a second. Any relevant equations that go with them. Where the pollutant is formed and what impact the pollutant has. So 4 different pieces of information for each pollutant. The pollutants we're interested in, there are 5 of them: carbon dioxide, carbon monoxide, nitrogen oxides, sulfur dioxide, and particulates. So when you're ready, I'm going to start to put together a mind map in the remainder of the video. So I've got my 5 pollutants there in the centre, and I'm going to start to add how they are formed. So carbon dioxide we're familiar with as a product of the complete combustion of hydrocarbons, such as those in crude oil and fuels. And carbon monoxide is formed if we have incomplete combustion of those hydrocarbons. We actually also have particulates forming in incomplete combustion of hydrocarbons too. That's where the fraction itself comes out of the car exhaust, for example, unreacted because there was a very limited supply of oxygen. Nitrogen dioxide is where we combust N2 at very high temperatures in car engines. Nitrogen is very, very unreactive, but in that specific circumstance, it will combust to form NO2. There's also a natural form whereby NO2 is made, and that happens with nitrogen in the air when lightning strikes. Sulfur dioxide comes from the combustion of sulfur impurities in fossil fuels. Now we're looking at combustion all the way around here. Combustion is always the combination with oxygen. So the N2 combines with oxygen to make NO2. The sulfur impurities in crude oil combine with O2 to make SO2. So I've done all of those in red. In green, I'm going to do the equations. So you're familiar with the complete combustion equations from previous topics, and similarly, you're familiar with the incomplete combustion equations from previous topics. When you combust something, remember, you add oxygen. Nitrogen is diatomic, so we react it with O2 to make NO2, and I've balanced that there with the 2O2 and the 2NO2. And if I'm going to combust sulfur, I combine S with O2 and I make SO2. There isn't an equation you need to be aware of for the incomplete combustion of hydrocarbons that gives us particulates. Going to move on, and in purple, I am going to give what they actually cause. CO2 causes global warming, and carbon monoxide is a toxic gas that causes suffocation. You need to be familiar with all of these facts. NO2 is a cause of acid rain. SO2 is also a cause of acid rain. And finally, particulates. Well, if you breathe in particulates, you might get breathing difficulties. It can cause lung disease, and you can get photochemical smog. You'll notice that I've done each of the types of information in a different colour. That is so I can decide I'm going to revise what impact these have, and I look for all of the purple. So using that colour can be really useful to pinpoint the relevant information. Similarly, I might want to just look at the equations. So I will then go to, right, I'm doing the green ones. I can go through, test myself. I'm happy with all of them. One final colour, because we did also ask for where the pollutant is formed, and we've done how the pollutant is formed. I'm going to race through this a little bit. Many of them are the same. Combustion of hydrocarbons we generally think of being in factories and car engines. We've got all of them on there actually saying the same thing, apart from NO2, which is limited to just the car engine that we spoke about earlier. So as a mind map, we've talked about one way that we can compartmentalise the information here. I'm going to do it now in a different way as well. What if I want to focus entirely on CO2 or CO or NO2 or SO2 or particulates? Well, once I've chosen colour in this way, let's use colour to map out one pollutant itself. And now I can focus on everything I need to know about CO without having to navigate through and identify precisely what the information is. Mind maps can be a really useful way to bring together large volumes of key information, and I'm hoping that this has been useful in helping you to see how you can construct them in perhaps a more effective way. That takes us to the end of this chapter and the end of this topic. Thank you for listening. Goodbye.